Bond order is simply the number of bonds. The bond order is 2 if you're dealing with a double bond, 3 for a triple bond, etc. And normally it's really straightforward. The times it gets a little bit more complicated, it's still not that bad, is when you have resonance delocalization. And let me give a few examples and you can figure out what the bond order is. Let's start with benzene. We're going to define the bond order as the number of bonds that are available, the number of bonds as you count them, divided by the bond locations that are available. In the case of benzene, we have two different equivalent structures, right? And it looks like we have 6 available bonding spots, right? Let's go around the horn. 1, 2, 3, 4, 5, 6. And each of them is really 1.5 bonds. I mean, look, this has spent some of its time being double, some of its time being single. So even without doing the math, hopefully you can see that the bond order here is 1.5. Things are halfway between single and double bonds. If you want to do the math, you can simply see that there are 9 bonds, right? 6 single, see the hexagon, plus the 7, 8, 9 bonds that are being used for 6 positions. 1, 2, 3, 4, 5, 6. 9 divided by 6 is 1.5. If that's not clear, try the nitrate anion. Here's your your 3 resonance structures. And in this case, it's all single bonds with 1 double bond that is distributed among 3 different positions. Can you see that its bond order is going to be 1 1/3 since that single bond occupies 3 different sites? I mean, that extra bond occupies 3 different sites. In this case, the bond order is there's 4 bonds, if you count them, 1, 2, 3, 4, divided over 3 positions. 4 over 3, the bond order is 1 1/3. What do you get for a nitrite anion? This is simply NO2. Number of bonds, 3. Number of positions, 2. Bond order, 1.5. Or to explain it without doing the math, you have a second bond, but it's divided over 2 positions, so the bond order is 1.5. This is bond order.